Hi, welcome to Reefer, your one-stop shop for analyzing the health of your ocean ecosystem. Reefer uses machine learning to analyze a set of images of coral reefs, which are one of the most important organisms in the ocean because they provide a habitat for many other species, including fish and algae. Reefer is intended to help speed up the time that marine biologists take on analyzing the health of the oceans. For example, they can spend the majority of the time in the water just taking photos and then quickly run the model to tell what of the photos lead to healthy coral or unhealthy coral. Because we're not marine biologists, though, we don't have access to tons of images of coral that we've already taken photos of, so we turn to Google to find a bunch of randomized images. Here's one that we quickly selected. It's just a basic random image, and we hit upload, and we can see that the image populates our dashboard. Quickly observe that this coral reef is probably pretty healthy. It's very red. It has lots of nice vibrant colors, so it's probably an unbleached coral, and it's probably pretty good. Let's check what our model says. Our model is ResNet. It's a pretty crude and basic simple form of machine learning, but it achieves 97% accuracy, which is much, much better, if not the best form of modeling that's available right now, with a paper in Nature last year only achieving 96%, which goes to show you that just by achieving hyperparameters, we're able to actually achieve large amounts of accuracy without having lots of data or a transformer. So as we can see, our result classifies correctly, it's not bleached, and it's very, very confident, 99.6, which is very high. We then use the Gemini API from Google to actually test and tell why our model was achieving the conclusions that it did. We use Gemini to basically interpret and create interpretability around our model. So as we can see, the image shows a vibrant coral colony, which is rich in red coloration, which is something that we observed earlier on. And this implies the presence of healthy zooxanthellae populations. So as you can see, Gemini is going a step further to sort of explain why the model is reaching the conclusions that it does, using inference and knowledge about biology as a whole from zooxanthellae. It then explains that this complex branching structure also just healthy growth, which is another reason why the model selected that it's not bleached. Then it goes on to characterize why we're so confident, namely because of the clear and distinct visual indicators of coral health present in the regime. We then can rerun the model on an bleached image. So here we'll drag and drop a bleached image, and we'll do the same procedure again, hit upload. And as we can see now, this is very clearly bleached coral. It's discolored, it's white, doesn't look too tasty or too good. We can check again by analyzing. And while we wait for the model to run, we can talk a little more to Gemini. Gemini is super cool because it offers a validation check on what we're doing. Although our model basically never misclassifies, if it did, Gemini would alert it and say, hey, this model probably misclassified. And you can check our dev post for an example of how Gemini can actually cross-check and validate our general classification model result, which I think is pretty cool. So let's turn back to our analysis. Our model pretty much spits out the correct value because it's bleached, and it's once again super confident, 99%. Gemini once again provides interpretability. It tells us the image shows bleaching of coral, which is a clear indication of stress and poor health, and it tells us why the bleaching occurred, mainly because zooxanthellae has gone away. And it tells us, moreover, that this is the cause of the white and brown images we're seeing. That's why the coral is losing its color. And then it provides a metric of why the confidence score is so high. It's because it's a clear metric of how unhealthy the coral is. So that's the model that we currently have. But throughout the hackathon, we tried to do a bunch of other things as well, which you can read about in our dev post. The first thing we tried to do was create a NERF, which basically takes a one single image and creates a 3D model. We were able to achieve some results, like turning a coral reef into a bird into a 3D mesh. It's kind of confusing, but check our dev post for a pretty cool image of what we ended up doing. Although that isn't quite presentable, so we didn't achieve our final model. Moreover, we also tried to achieve 2D super pixelation and super zoom by doing sort of the same NERF transformations. We did sort of achieve goodish results, but they weren't the best, so we also didn't include them on our model. But once again, you can check out the images in our dev post to hear more. But all in all, we still feel that our model is pretty good. And with more time, we'd like to add these features. But right now, as a bare bones classifier that works nearly 100% of the time, we think that Reefer will be an excellent tool for marine biologists to use in the future. Thank you for checking this out.